Hi everyone, my name is Adelia and this is my final project for Intro to Material Science. And today I will be talking about metal forms, what they are, what makes them special, and why scientists and engineers are so interested in them. So what is metal form? It's exactly what it sounds like. A metal that has been turned into a foam full of tiny holes or pores. These holes make the material much lighter while still keeping some of the strength and durability of solid metal. Metal foams are unique because they are combined two opposite qualities. They are lightweight like plastic foam but strong like metal. This mix of properties gives them a lot of potential in fields where we need strength, but also want to save weight like airplanes, cars, or even medical implants. There are two main types. Closed cell foams, where the holes are sealed and don't connect. These are better for structural support and insulation. Also, there's open cell foams, where the holes are all connected. These allow air or fluid to pass through, making them useful in filters, heat exchangers, and even bond scaffolds. Manufacturing processes. There are a few different ways to make metal foam, depending on the desired structure and properties. Here are some of the most common methods. Gas injection method. In this method, metal, usually aluminium, is melted and gas like air or nitrogen is injected while stirring the liquid. Stabilizing particles like silicon carbide are added to prevent the bubbles from collapsing. The metal is then cooled quickly, trapping the bubbles inside. This creates closed cell foam that's useful for lightweight panels or floating devices. Blowing agent method. This one uses a special chemical called a blowing agent, like titanium hydride. When it decomposes at high temperatures, it releases gas and forms bubbles inside the molten metal. This also results in closed cell foam, but with more uniform pore sizes, which is good for crush absorbers and thermal insulation. Space holder method. Here, a filter material like salt or sugar is mixed with the molten metal or with powdered metal. After the metal hardens, the filler is removed by dissolving it in a water or burning it off. This leaves behind an open cell structure that's ideal for fluid flow, like in heat exchangers or by medical implants. Dissolved gas method. Metal is melted under high pressure hydrogen gas. The gas dissolves into the metal and forms pores when it cools. This method can also create directional pore structures, which can be useful in advanced designs like lotus type foams, which shown in the picture. Powdered metallurgy and 3D printing. In the powdered method, metal powder is mixed with a blowing agent or a removal filler, pressed into a shape and heated. This allows precise control over the foam structure. With additive manufacturing or 3D printing, we can directly design and build foams layer by layer, allowing complex shapes that are hard to make by traditional methods. In material science, metal foams are exciting because their porosity, the amount of empty space, affects how things like heat, stress, or even fluids move through them. More porosity usually means faster diffusion of gases or liquids. The shape and size of pores also influence how the material behaves, and of course the type of metal matters too. Aluminium behaves differently than titanium or copper. The internal structure affects how strong or flexible the foam is. Closed cell foams are stiffer and resist compression better, so they are great for supporting weight. Open cell foams are softer and absorb energy well, which makes them ideal for impact protection like in helmets or car bumpers. Foams also behave differently when it comes to heat. More metal means better heat conduction. Closed cells trap air, making them good insulators. Open cells allow airflow, which is better for a cooling system. There is always a trade-off between thermal performance and mechanical strength, so engineers have to choose based on what's most important for the application. As we go for 3D modeling, This is the structure of the metal, and a combination of these metallic structures creates a metallic form. So they create this kind of metallic form, which consists of pores, which are of different sizes, but they can be of the same sizes too. Metal foams have a wide range of uses. In cars and planes, they reduce weight and absorb crush energy. In medicine, they are used for bone implants because the open structure allows bone tissue to grow inside. In electronics, they help with cooling systems, and in energy systems, they are used as filters or catalysts. To sum it up, metal foams are an exciting material with a lot of potential. They are strong, light, and can be designed for all kinds of advanced uses. As technology improves, we will likely see them used even more in everyday life and in high-tech industries. Thank you so much for listening. Yeah, thanks so much for listening.